Hi guys, I'm Sai Krishna. So let us look at question number 2. In question number 2, we are told to collect the definitions of properties of stochastic process and explain our understanding about the process. So let us look at the solution for this. So by sense stationary process, uh, we basically we define Whiteson stationary process, stochastic process, where mean is constant and autocorrelation is a constant function of time difference. Okay, so this is what I've understood from Whiteson stationary. Coming to independent increment process, so a process can be said to be independent increment, um, uh, where x of t1 minus x of t2 and x of t3 minus x of t4 are on non-overlapping intervals are independent. So basically they are independent. So these three processes are my understanding of these processes is that basically Poisson's process, random walk, and Wiener process are independent increment process. So let us look at Markov process. So Markov process, a process said to be a Markov process if the past has no influence on the future when the present is known. So these are the Markov processes, which is Poisson process, Poisson impulses, semi-random telegraph, random walk, Wiener process. So I've basically collected all of these from the class notes. So let us look at 4, which is normal process. So in the normal process, a process x of t is said to be normal if the density function is given by this big equation, and where the values are defined by these respectively. So by normal process, we basically mean that it's a very broad process, and it can also be said to be a property of stochastic process as a whole. So this is what I've understood from normal process, sorry. So let us look at strict sense stationary process. So a process said to be strict sense stationary if its statistics is not affected by a shift on the time axis. So basically the density function remains same uh, with respect to x and t with the change in epsilon as well. So this is what I've understood about strict sense stationary process. So white noise, coming to white noise, the sixth one. So a process v of t is said to be white noise if it is a differential of Venus process, and expected value of 0 is 0, and the RV T1 comma T2 is defined by this equation. So coming to the last one, which is mean ergodic. So a process said to be mean ergodic if the limit value becomes e of x of t in means square sense. So basically this means that this is a constant value. So basically from all these I've understood that um, to sum it up, these are the things that I've observed about the Whiteson stationary, the independent increment process, the Markov process, the normal process, and the strict sense stationary process, white noise, and the mean ergodic. Thank you.